My name is Leslie Marsh. I'm an Associate Instructional Designer at Sinclair Community College in the e-learning division. In this video, I will discuss the cognitive load theory and the cognitive theory of multimedia learning and how both theories are related. Cognitive load theory focuses on designing learning to optimize the constraints of the mind's cognitive architecture. Successful instructional design should reduce extraneous cognitive load and manage the intrinsic cognitive load in order to optimize the learner's germane cognitive capacity. But what does this mean? Let's start with vocabulary. Cognitive architecture refers to two key concepts: working memory and long-term memory. There are natural constraints on processing, including distractions in the environment and the intrinsic difficulty of the material that's being presented. The extraneous cognitive load is the load on cognitive capacity that is caused by distractions in the environment or by poor lesson design. These distractions could be someone walking by or perhaps flashing fonts in the design of the lesson itself. Intrinsic load is the load on cognitive capacity that is due to the difficulty of understanding the material itself, the essentials of the material that are being presented within the lesson. It is due to the inherent complexity or unfamiliarity of the material to the learner. Germane load is the net effective cognitive capacity of the learner once the extraneous and the intrinsic cognitive loads have been combined and taken into account. Essentially, it is the mental power that's left over for processing the new information. Long-term memory represents the learner's knowledge base or information store. It consists of schemas or mental models which have been constructed over time. These schemas efficiently store information in long-term memory. Schemas can be either primary biological information. Essentially, it's knowledge that we need in order to survive and does not need to be taught to us. Schemas can also be biologically secondary information. This information is culturally based and is taught to us. It's also acquired over a lifetime of experience. Both types of schemas may have other types of schemas embedded within them. To change the schema in long-term memory, the schema must be brought into the working memory and integrated with the new information. Then, a new mental model is built and stored within long-term memory. The cognitive theory of multimedia learning consists of three main assumptions. The first assumption is that there are two main channels through which we process information as we learn. The first is visual, which takes in pictorial or written information through the eyes. The second is auditory, through which we absorb sounds or speech. These channels can cross over during processing. For instance, a visual may be processed in the mind as a vocabulary word that is mentally spoken, or speech may create a mental picture as it is being processed. The second assumption is that each channel has finite processing power, and that either channel can be overloaded due to poor design or due to distractions in the environment. The third assumption is that learning is an active process that consists of selecting, organizing, and integrating information. Selecting relevant information from all of the stimuli coming in, organizing it by understanding the information based on prior schemas that are known from long-term memory, and then integrating the information into those schemas and storing it again in long-term memory. There are three basic memory stores involved in this process. The sensory memory takes in incoming information to process. It is very short-term. Working memory actively selects which information to pay attention to and retrieves existing mental models to make sense of it. Long-term memory is where the schemas are stored. Learning occurs when the new information is integrated with existing schema and stored in the long-term memory. The integration of new knowledge causes incremental changes in the schema in long-term memory, not large jumps. Instruction should be designed to provide clear and concise verbal and visual information. Should use cues to help learners focus on relevant, essential information, and should cut out any extraneous details, anything that's distracting, so that it's only essential information being presented. All of this reduces the load on the learner's cognitive capacity, leaving as much processing power as possible for the learner to generate new schema from the incoming data. Both theories are based on the idea that there is limited working capacity in the working memory, that distractions in the environment or in the way that learning materials are presented can overload the working memory's ability to process the information and select what is relevant in the details. Both theories agree that the new information could be so complex that it is difficult to comprehend and could overload the mind's processing capacity, and that successful learning takes place when distractions are minimized and the material is presented in a way that allows the learner to grasp it with lower effort and have enough capacity to integrate the new information into existing mental models.